Assalamualaikum and hi. Okay, in this video we're going to continue with our module 5. This video we're going to cover our part 5.5, which is control unit operation. There will be cover overview, micro operation. What is micro operation? And then control of processor. So these three subtopic, I guess it's only few slides, so this video is not too long, quite short, I think so. Okay, depend also about my explanations. Okay, now we move to the overview. So about the overview, here we have to know the external interfaces, usually through a bus, isn't it? And how interrupts are handled. Six items might be termed the functional requirement for a processor should do and being controlled. So one of that is operation, which is the opcodes, addressing modes, registers, input-output module interface, memory module interface, and lastly interrupts. So this is the 6 items you need to remember that might term the function requirement for a processor should do and begin control. This is a new term for you. Last time you just know operation. Now later on you will see there is a sub operation, micro operation, and so on. So this is micro operation. What is micro operations? The operation of computer in executing a program consists of sequence of instruction cycle with one machine instruction per cycle. So let's say you have a program. So you have a program, you want to execute it. Whenever you execute the program, which is your source code, it consists of several instruction. Your source code, maybe line 5, line 6, 7, and etc. So each of these is an instruction. In your previous sub module, you look it as a single instruction per one. So your program consists of sequence of instruction cycle. This is one cycle, and then you have another one cycle, another one cycle, another one cycle. So it's sequentially having a sequence of instruction cycle with one machine. This is your laptop or computer. With one machine instruction per cycle. So per cycle, you have one machine. Basically, your processor also will do it sequentially one by one until you finish reading all the instructions listed in the program. Each instruction cycle is made up of numbers of smaller units. So maybe you have one instruction, but you can divide it into small pieces of units. One subdivision that we found convenes is fetch, indirect, execute, and interrupt. Okay, this is what happened in your last subtopic. You will see that this example, okay, this example is okay, this one line is called as a single instructions. So a single instruction, when you execute it, per line by line, you will see that this will finish for one cycle. Before you step over to this, and this will be finished, it is one cycle. And this cycle, last subtopic, you look that it can be divided into several, which is fetch first. This is the first one that we'll do. Please remember back what fetch are doing, the decode, and also maybe if your operands, I forgot, but you need to have the interrupt if needed. And after fetch, you're going to do the execute. So you're going to do the execute. So how about the execute? What execute do? After your execute, you're going to also have I forgot what. Cannot think. Until then, after that is follow, and sometimes you also can have the interrupt over here. Sorry, interrupt is here. And over here is your indirect. So sometimes you can have indirect operand, and also sometimes it's direct to execute, and maybe you can also have a fetch direct to your execute. So this is the normal one cycle. So you call it as smaller unit because you can see that one cycle you just debug and you get one cycle. But inside one cycle, you can have it as a smaller unit, which is fetch, execute, and also interrupt. But you might also have the indirect. With only fetch and execute cycle always occurring, means that fetch and execute is a must. Right? So each of the smaller cycle involve a series of steps, each of which involve the processor register. So you have also we're going to involve with the series of steps. Of course, if you look back last subtopic, last submodule, fetch you have about 3 steps. Same goes to execute. There is several steps, which is series of steps that involved, and it also involve a processor register. This series of steps, which if you see, wait, I write first. Okay, if you see, why it's delay? If you see that in your last submodule, you have like a table. What is the task for each fetch and then execute and so on. So fetch first, you're going to fetch your instruction. Second, you're going to decode, isn't it? You're going to decode. So this step inside one smaller unit, which is called as series of steps, known as MicroOperation. So how I'm going to draw it? Okay, let's say one cycle. You have one cycle. In one cycle, you can divide it into several smaller unit: fetch, execute, interrupt, and indirect. And in each of these smaller unit, you must have a flow, which is smaller cycle. It's called this one. Maybe I'm not going to do like this. Maybe you can have like this, so you can see it clearly. But it's going to be in sequence, right? So this part, when you have this over here, all of this is known as MicroOperation. Okay. This this is much more clearer than my drawing. Okay. You can see that you have a program executions. Program executions of your source code. There are a lot of line, of course, in one program. And each of this is instruction cycle. How many instruction you have? You will do like this. So this is one instruction or single instruction. So instruction cycle. And you can divide one single instruction, one cycle, to be divided into fetch, indirect, execute, and interrupt. And of course, under fetch, there are several steps that fetch will do. Like first, you're going to fetch the codes, and then after that, you're going to decode, and so on. So all of these are known as micro operation. Okay, let me see this one. Okay, a program execution consists of sequence of executions of instruction, and then this called as sub-cycle. Same goes to your previous 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 page. Smaller cycle, okay, which is known as sub-cycle. After that, you have each sub-cycle involve one or more shorter operations. It's called as micro-operation. Easy to understand. Okay, that is about the overview. So you now you know about the overview, and also what is micro-operation, because this is new term for you, right? Now you already know what is micro-operation. Next, we're going to move control of the processor. The basic of the design and implementations of control unit are based on definitions of function requirement. Three-step process lead to a characterizations of control unit or your CU. First, define basic elements of the microprocessor. Second, describe the micro operations that the processor perform. And third, determine the functions that your CU must perform to cause the micro operation to be performed. So this is the flow and step. 3 step only for the process lead to the characterizations of the CU. Where's my... Okay. We're going to move to our next slide. Okay, basics elements of the operation. This one we already, I think, repeat several times. This is just look like a recap because you already know what is element inside a processor. If you look here, your processor, you know that it have ALU, CU, control unit, and register. And beside of that, you know it's going also have the uh, connection to each other. It is internal data part and external data parts, which is the one that control your movement inside your processor and also to the outside. So ALU, what is the basic function? I guess you already have several time of recap what is the function of ALU. But in this slide, it shows that the basic function element of the processor itself cause operation to happen within the processor. Register used to store data, also status internal to the processor. Internal data part used to move data between register and between register and ALU. And for external, link register to memory and input-output module, often by means of a system bus. Of course, you need a system bus. Micro operations of the processor performs. A micro operation, which is your micro operation, of course, fall into one of the following category. It can be either one: transfer data from one register to another register, transfer data from register to an external interface, transfer data from an external interface to a register, and lastly perform an arithmetic or logic operation using register for input and output. So there are 4 types of micro operations. Okay, under control unit functions, you can divide it into 2 main categories. This is functional descriptions of what your control unit or CU does achieve through the use of control signal. So you can see it can be divided into 2 main tasks, which is sequentials and executions. The CU causes the processor to step through a series of operation in proper sequence based on the program being execute. While for executions, you can see the CU cause each micro operation to be performed. So this is the task of your CU. In this slide, it shows you that your CU perform its functions. It must have input and also output. So input that allow it to determine the state of the system, while output allow it to control the behavior of the system. You can see this is your CPU, which is CPU, your CU, which is control unit, specification, you have input and output. What input does and what output does. Input like your clock, your instruction registers, your flag. Oh, flag also your input, and also control signal from control bus. While for output only have two, which is control signal within processor, and lastly control signal to control a bus. This one, this come and give here. This is the block diagram of your control unit. Last time you just see it in a box. Now you will see what is basically happen. You have several port. Is it port? So you can see you have several input. Input from your flag. You have several flags, so this might be one of the input to your CU. Clock is also one of the input. If you still remember here, you have clock, you have flag. How about instruction register and also control signal? So this is your instruction register, and if you have the control bus, you're going to see it's going to have a connection vice versa, which is control signal from a control bus as an input, but while control signal to the bus is the output. And for the output, another one is control signal within your CPU. So red color is input, green color is output. So this is how your CU look like. Although you maybe last time you just see this is your CU, this is your CPU, and you have over here, let's say, register, and maybe you have your ALU. Sorry, my drawing. ALU. So you just see like this, and some part also you see the connection to each other, but in detail you don't know what all the connections for. So now you see you have several input from flag, from clock, from instruction register, and another one from your control bus. While you have two output for control signal within CPU, and another one control signal to your control bus. This one, this table is the inputs of CU specifications about your clock, instruction register, flag, and also control signal from control bus, control signal within the processor, and lastly your output is control signal to control bus. So all of these have okay, this one is input, this one is output, sorry. Okay, all of these has their own task, and we describe it here. For clock, this is how the control unit or CU keep time. So this is the use for your
It's
clock.
0 hours.
Why you need clock for your control unit. And about instruction register, the opcode and addressing mode of current instruction are used to determine which microoperation to perform during the execute cycle. And flag, they are needed by CU to determine the status of processor and the output of previous ALU operation. Lastly, for your input is control signal from control bus. What is the task and description is the control bus portions of the system bus provide signal to the CU. And now we look into the output. So the output only have two control signal within the processor, which is there are two types. Those that cause data to be moved from one register to another, and another one is those active specific ALU functions. These are also of two types: control signal to memory and also control signal to the output input output module. So you can see over here, this is the data parts and control signal. Last time you see this MBR. What is MBR? It is a memory buffer register. You also have a look into MAR in your last subtopic, which is called as memory address register. You also already look into PC, which is program counter, IR, your instruction register, your SC accumulator, of course, this one, and this one and this one, no need for me to introduce, your ALU, arithmetic logic unit, and your control unit. Now over here you can see there are several tasks for each other. What basically C1, C2, C3 and so on is going to be shown in your next slide. So this one you can see terminologies of the control system. So what is this all function? Okay, now you can see it is all listed here. Active control signal. You need to know there are several steps, and each of step will only use several functions. Let's say for fetch, it's only use C8, C1. For education, C4, C6 maybe. Okay, now in here it shows you everything, which is under fetch. It has three time, T1, T2, T3. First, this one, all of this operation already done in your last previous subtopic. You can see from PC, you're going to get the value and you're going to store into your MAR. So it is under C2, active control signal. So where is your C2? So from your PC, you're going to store the value to your MAR using your C2, which is your control signal. And next is under MBR. From memory to your MBR, and you're going to increase your C2. So it's going to occupy you CR, which is read control signal to bus, which is of course you increase one value over here. And this one you're going to see you also use C5 and CR. So what happened is from memory to your MAR. So you're going to have your register. So it's going to go to your MBR, sorry, using C5. And next is your from MBR to IR. Let's take a look. MBR to MBR to MAR. So it's going to use C8 M sorry, MBR to IR. Sorry lah, dah tua. MBR to your IR. So this is this control signals that will involve. So in this table, you were listed with all the process, all your micro operation process you already learned in your previous subtopic, and you going to occupy and use only that active control signal shows in this data part and control signal figure. For indirect, you're going to do this step by step, and it will occupy what of the control signal that will going to be active at that certain instruction or task, but it is mostly a micro operations. So please try take a look all this micro operation, although you already know because we already learned in our previous subtopic, but maybe you can see the correlation and the relations of your active control signal with your micro operation. So that is only for your 5.5 module. Later on, we're going to move to our new subtopic, which is microprogram control. So this one we're going to cover in our next video. So thank you for watching this video. Please stay safe and still happy Ramadan. Bye bye.